Hi, everyone. Welcome to our MolSSI Python visualization workshop. So today what we're going to do is we're going to be learning about some visualization libraries in Python. We're going to be seeing, really the goal of this workshop is to learn to make, we'll say, presentation and publication quality figures using Python libraries. So that is the goal of today's workshop. We are holding this in collaboration with the Comp division of the American Chemical Society. I'm joined today by Dr. Ashley McDonald, who is the helping instructor and also, I think, you're chair of the Comp division, right? No,
I'm really chair-elect. I'll be chair next year.
Okay. But Dr. McDonald, do you want to introduce yourself more?
So, hi, everyone. My name is Ashley Ringer McDonald. I'm a faculty member at Cal Poly San Luis Obispo in California. I'm also, as Dr. Nash said, I'm the incoming chair of the Computers and Chemistry Division of the American Chemical Society. And Dr. Nash and I work together at the Molecular Sciences Software Institute, where I am the co-director for education, and Dr. Nash is the software scientist who directs our education programming.
Yes. Thank you, Dr. McDonald. So that makes me realize that I forgot to introduce myself. My name is Dr. Jessica Nash. I have a PhD in materials science and engineering, and I am a software scientist at the Molecular Sciences Software Institute. The Molecular Sciences Software Institute is the organization that is kind of hosting this workshop. And we're going to start out with just a little bit of an overview of what the Molecular Sciences Software Institute is, and that's what these slides are. So I will go ahead and get started with that. So since you're in this workshop, we're just going to take a few minutes to discuss the Molecular Sciences Software Institute. So our tagline is a nexus for science, education, and cooperation for the global computational molecular sciences community. And what we at MolSSI do is we develop software and we hold education, trainings, things like that to serve the computational molecular sciences community. So we pronounce it short name MolSSI. Okay, all right. Okay, so what is the MolSSI? We were launched on August 1st, 2016. We initially had 5 years of funding and were funded by the National Science Foundation. This was a collaborative effort between many different universities, and MolSSI is designed to serve and enhance software development in the fields of computational molecular science, which is a broad domain that includes quantum chemistry, computational material science, and biomolecular simulation. Very importantly for us, or something that we're very happy about, is that our funding was renewed for an additional 5 years last year in 2021. So MolSSI is going to be around for at least 5 more years. Here is our board of directors. Dr. McDonald is on the lower left here. She's already introduced herself and she's joining us today. But we also have a number of other professors on our board of directors. So there's Daniel Crawford, who is in the upper right corner. He is the director of the Molecular Sciences Software Institute. He's based at Virginia Tech. And that is where MolSSI is based also. But you'll see from our board of directors that we have a range of different scientific expertise and fields. So some of our board of directors are computer scientists. Some work in, say, molecular mechanics. Some work in quantum mechanics. And then, so we've really, we're trying to represent sort of the whole domain of computational molecular science. MolSSI has 3 goals. We usually present 3 goals that we have, and I'll go over those. Our first goal is to provide software expertise and infrastructure. So we work with different research groups internationally and across the United States to design, develop, test, deploy, and maintain code infrastructure and frameworks for the entire community. We try to establish standards, set software priorities, etc. So that's our first goal, is to provide software expertise and infrastructure by interacting with the computational molecular sciences community. Our second goal is to provide education and training. And by participating in this workshop today, you're participating in our education and training programs. So we organize summer schools, workshops, undergraduate training programs. We have online resources and classes that we use to kind of train researchers in the computational molecular sciences. And then our third goal is to provide community education and leadership. And so will enable the CMS community to establish its own standards for interoperability, best practices, and curation tools. So this is just interacting with the community in order to improve computational molecular sciences software. So for our training programs, we call that falls under the umbrella of what we call MolSSI Education. And MolSSI Education has been pretty active since 2017. We've had over 1,200, and this is a low number now. It's higher than this. Students participating in, say, synchronous workshops like this one. So our curriculum at MolSSI Education is languages and tools used by software developers and data scientists in the context of computational molecular science. So we cover things like programming languages, software development practices like version control, testing, things like that. But we cover it in a way that's relevant to scientists and researchers who are working in the computational molecular sciences. We try to engage audiences who are global and diverse, and we have a number of organizations that we work with in partnership and collaboration. These are some pictures from MolSSI Education, sort of when we can have in-person events. We really enjoy having those. We also really like having these virtual events like we're having today. And then this may be of interest to some people in our workshop today. I always like to advertise our MolSSI software fellowships. As of this year, they're available as yearly fellowships, and they last for 12 months. And as part of this fellowship, you have to be working on a software project related to computational molecular science. But if you're awarded a fellowship, you are mentored by a MolSSI software scientist, and you also receive, say, funding for a year. So it's a very nice fellowship. Students who apply to this do need to be at US institutions. And I think that we have, hopefully it hasn't closed. I think that the fellowship applications are open now, but they may close very soon. I should have checked that before I put the slide in, but at least be on the lookout for them next year, maybe. And then this is a little bit about our software fellowship program. We've been going for about 4.5 years. We've had 85 fellows go through our fellowship program, and most of them have said that their fellowship has been very beneficial to their research or project or to their career. So just another plug for our software fellowship program. Okay, so that is what I had for the presentation on MolSSI. So hopefully that gives you a little bit more of an idea of what MolSSI is and sort of what we're about and how you can get involved with more activities related to MolSSI. So for our workshop today, we're going to be using some Python libraries, Matplotlib, Plotly, and maybe NGLView to create visualizations in the Jupyter Notebook. There were two ways that I sent in the directions to create to access the Jupyter Notebook. One was through a website called NanoHub. One was through a website called ChemCompute. Or if you have like Python installed on your computer already, you're perfectly welcome to use that. So for everyone in this workshop, whether you're using ChemCompute or NanoHub or just Python on your local computer, you're going to need to have this GitHub repo cloned. If you're using ChemCompute or NanoHub, there was a link that told you how to clone those on those environments. So I am using ChemCompute today. So yours may look a little bit different than mine, but if you're using ChemCompute, you go to compute.org, and then go to Jupyter, and then use Sci4 or Jupyter Hub. If you have cloned the repository, you should be able to find it from there. So I'm going to go back out to this tab. I have a folder here called MolSSI Python Viz 2022.git. If you're using ChemCompute, then it's going to show up with this .git at the end. So I'm going to click on that. So I have my folder cloned, and then so I'm looking at my home directory. I'm just going inside of that folder that I cloned, MolSSI Python Viz 2022.git. And then in this folder, we've got a collection of files that we're going to use to that we're going to be visualizing. So we'll be using all of these files today to make various plots. So we're going to start with learning a little bit about Matplotlib. And so we'll start by creating a new Jupyter notebook. So I'm going to go to New Python 3. And then I'm going to give this a name. So this will be my Matplotlib notebook. And then I will make this first cell a markdown cell just to make my notebook look nice. And then my title will be plotting with Matplotlib. And to execute a cell in the Jupyter notebook, you can press Shift and Enter on your keyboard at the same time. Okay, so in this workshop, we're going to use Matplotlib, and the data, a lot of the data that I've included here is data associated with hydrogen atom orbitals, which if you are a chemist, you will probably have some familiarity with. And so these are things that you kind of look at in your intro quantum classes. But even if you haven't taken quantum chemistry, I think these will kind of be familiar to you. So we're going to be working with pre-calculated data that's in CSV files. You should have those already. We just went over that. The first thing that I want to cover is that we're going to, in order to read those files, we're going to be using a library called pandas, which many of you may be familiar with. But I just want to briefly go over how to use pandas, give a little tutorial on how we're going to be using pandas so that everyone is familiar with that as we move forward. So I'm going to have another markdown cell where I'm just going to have a little subtitle that says using pandas. And so pandas is a library that's really commonly used in Python for data science. The key feature of pandas is that it has a data structure called a data frame. And pandas is very good for reading and working with data that is what we would call tabular or has rows and columns. We have CSV files, which are text files that are comma separated value files, meaning that they are files that have values separated by commas. So it's a lot what it sounds like. And pandas is very good for reading in these type of files. So we're going to read in our first file, which the first file that we're going to work with is called sorbitals1d.csv. So to get started, I will import my pandas library. And we typically do import pandas as PD. And then I'm going to create a data frame. And I'm going to say sorbitals equals PD, and then I'm going to use the function in pandas called read CSV. And then I'm going to put my file name, and my file name is sorbitals1d.csv. And that was, if you're curious, I'm just going to click back out here so you can see that that file is included, say here in those files that you downloaded. So I'll press Shift and Enter to execute this cell. Uh-oh. Oops. I had a typo. There we go. So if you typed your file name correctly, that should execute without any problem. And if you want to make take a look at what we have, you can use this sorbitals dot head function. So this is going to show me the first 5 rows of my data. This is a little bit of a pandas intro in case you haven't used pandas before, but this is what we get when we use this read CSV function. Right here, this is called a data frame, and when I do dot head, it's showing me the first 5 rows. But the read CSV function has read the information from that file into basically a table, and we have our column names, which our column names are R, 1S, 2S, and 3S. And then we have our rows numbered on the side. So this is more than 5 rows, but I'm just seeing the first 5 because I'm using this dot head function. So if you look at this, you can see that we have something that kind of resembles a spreadsheet. So this kind of looks a lot like Excel to me. And this is called a pandas data frame. So I just want to give a brief introduction to accessing data in a pandas data frame, because this is going to be important for the rest of our workshop. We're going to be using Matplotlib and Plotly with pandas data frames. So to access data in a pandas data frame, one thing we might want to do is access the values in a particular column. So if we want to get, so this is a note, to access values in a column, we give the data frame name and then square brackets, and in parentheses, we type the column name. So that's how to access information in a pandas data frame. So for our example, if we want to get the column R, we would do S orbitals, square brackets, and then quotes, and then we would put R inside of those quotes. And so that is going to give us all of our R values. The second way I'd like to cover accessing data in a data frame. So this is the first way. We only need to know 2 ways for this workshop. This is the first way, using square brackets in the column name. And then the second way is by using something in pandas called the iloc function. And so I'm just typing, I'm going to move this up a little bit. So in pandas, there's also a function called iloc, and we can use that to slice the data frame or access particular rows or columns. So the syntax for that is data frame.iloc, and then row slice, and then column slice. So if you're familiar with NumPy arrays, and I kind of want to scroll up so you can see this too. If you're familiar with NumPy arrays, this is very similar to how you can slice NumPy arrays. Okay, and I'll demonstrate that. I'll do S orbitals. And let's say I want the first 10 rows, well, S orbitals.iloc. If I want the first 10 rows, I would do something, I would do :10 to give me the first 10 rows. And if I want only the first 2 columns, I would do :2. So this is just an example of slicing values with a pandas data frame. Yes, okay. So pandas is one of my favorite libraries. I think that this way of accessing data in the data frames is really useful. You'll see pandas used a lot, say, in conjunction with other libraries. Like, I think we have a workshop that, well, not I think, we have a workshop that we do with NVIDIA, that's Fundamentals of Deep Learning, that uses data frames and TensorFlow. Okay, so I just want to execute this cell to demonstrate. So this is just demonstrating getting a subset of our data frame. So this isn't plotting yet, but it is information that I wanted to cover so that when I use this sort of syntax later in the workshop, you'll kind of know what I'm talking about. So what we've done so far is we've used pandas to read in data from a CSV file. If you have an Excel file, pandas can also be used to read data from an Excel file. That's a different function. It's called read Excel. And then there are two ways that we're going to be using to access data in our data frame today. One of those is by using this syntax with columns, so square brackets and then in quotes R. And then the second way is using this function called iloc that we're going to be using to grab a specific, say, subset of our data frame. Sina, do you have a question?
Yes. So when we want that, let's say, R column, I can see when you use either of these methods, I get another column kind of concatenated at the same time. What should I do when I want to get rid of it?
Yes, so excellent question. So Sina is asking about these on the side. These are, so pandas likes to give us row and column names. Or it's really called the row index. So this extra column that we're seeing here on the side is the row index, and pandas just always likes to give that to us. If you wanted to get rid of that, then you could add dot values here, and that's going to give us just the values. So I could do that instead. So that's if you want to get rid of it. So that is really commonly used. That's really commonly used, I think, when you're working with machine learning libraries. We won't necessarily need it today, but good question. Okay. All right, so let's actually get started with plotting. So in this section, and I'm going to make a markdown cell. Now we're actually getting to Matplotlib, now that we know how to use pandas. So in this section, we're going to be creating plots using the Python library Matplotlib. And so Matplotlib is, I would say, perhaps the most widely used Python plotting library. It's been around for a while, I think since about 2003 or so. So Matplotlib is approaching something like its 20th birthday. It's a pretty big library. It's got a lot of capabilities. And so we're going to see some of those today. Really, with Matplotlib, you can make almost any type of plot you want to make, and you can customize it in almost any way that you can imagine. I would say a lot of times, like as scientists, we might not really fully utilize the power of Matplotlib. For the workshop today, we're going to try to get closer to maybe doing that by talking about some features in Matplotlib. Okay, so now that I've given that little intro, we can start using Matplotlib. And to use Matplotlib, the first thing that we have to do is import it. So we'll do import Matplotlib, and we're going to import pyplot, and we'll import that as PLT. So I'm going to add another command in my notebook or in the same cell. And this is a command that starts with a %, and this is a special Jupyter Notebook sort of syntax. So you can write Python code outside of the Jupyter Notebook, but this command that I'm typing here is going to be something that you can only use in the Jupyter Notebook. But I'm going to type Matplotlib notebook. And what this is going to do is it's going to make it so that my Matplotlib figures are interactive in my notebook. And you don't have to use this setting if you're making plots. I just like to use it, so I'm going to include it here. And I will also write a comment. Okay, and so that should execute without any problem. So the first type of plotting I want to talk about using Matplotlib is plotting using something called the procedural interface of Matplotlib. And if you've done plotting before with Matplotlib, I think that this is most likely the way that you learned how to do it. So I'll make a note, procedural interface. And for the procedural interface, we would do something like if we wanted to plot maybe s orbitals and we want r on the x-axis and 1s on the y-axis, then we might do something like plt. So that's matplotlib.pyplot.figure. This creates a new figure. If you use this Matplotlib notebook, then sometimes using this isn't necessary. If you use this magic tag, then you pretty much need to use this function every time you create a new figure, if you're curious about that, because you may not have seen this before. But we'll do plt.figure. And then if I want to create a plot, I'll do plt.plot. And then in parentheses, I put my x value, which is s orbitals r. And then I can put my y values, s orbitals, square brackets, quotes, 1s. And you should get a sort of figure that looks like this. You'll probably be able to see all of your figure. I'm zoomed in pretty far. Zoom out, but I can kind of scroll and see. So there is my figure. But this is using what is called the procedural interface. So if I want to keep going, so let's say I wanted to plot 2s and 3s, so I could copy this. And I could maybe do 2s here, etc., until I kind of got what I wanted on my plot. Then if I wanted to make, sort of using this way of creating figures, if I wanted to create another figure, I would do maybe plt.figure in this cell, and then I would plot what I wanted on that second figure. So the sort of important thing to note in this situation is that if I want to add that every time I call plt.plot, a line is added to the most recently created figure. So let's say I create 2 different figures, and then later I wanted to add something to a previous figure. Just using this plt.plot interface, there's not a good way to do that. You would need to scroll up and maybe re-execute this cell. So in the Matplotlib procedural interface, every time you add a plot, it's added to the most recently created figure. I want to discuss Matplotlib's object-oriented interface. And when you use Matplotlib's object-oriented interface, what's going to happen is that you'll have a variable that represents each figure. And so you can have multiple variables for different figures at once, and then you can kind of work on all of them, at different times. This, along with some other things, allows you to have a lot more control. So working with the figures and the axes as variables or as objects allows you to have a lot more control over the figure that you're creating. So I want to show how to use that object-oriented interface for Matplotlib. So this was the procedural interface. We create a figure, we call plt.plot. And then every time we call something like plt.plot, it's going to add to the most recently created figure. So let's see how we could do sort of the same plot with Matplotlib's object-oriented interface. Okay, so I will make a cell here. I'll call it object-oriented interface. Okay, and then we'll use a different method to create a figure. So this time, instead of doing plt.figure, I'm going to say fig, comma, ax. equals, and I'll do plt.subplots, and then open and close parentheses. So I want to show what comes out of this. So I'll do, when I do use plt.subplots, it's going to show a figure for me. You'll see that it is labeled as figure 2. And right now we just have a figure that has nothing on it. So we just have an empty figure. The important thing to note at this point is that we have these two variables, fig and ax, and these are variables that represent the figure and variables that represent the axis. So say this X and Y axis. Okay, so now if we want to add something to this figure, so let's say that we want to add a line to this plot I've created, instead of using plt.plot, we are going to use this axis object that we created, or this axis variable. And so we would do this very similarly to what we did before. We could do ax.plot. So now instead of calling plt.plot, we're going to do ax.plot, so the variable instead of plt. And then we'll put the same thing in parentheses, except I'm going to teach you a slightly different syntax now. So if we're using a pandas data frame, we can do this. We can put R in quotes and then 1S. So these are our column names. And then we can put another argument here called data. And we're going to set that equal to S orbitals. Okay, and this has added the line to our figure that we created previously. And so we had a question in the chat if fig and ax are the same thing. They're actually not the same thing. So fig represents this whole thing. Like this whole, and this will become very clear when we're going to do subplots. Fig represents this whole thing. So like this white space here, and ax, they are not. You can name them. They're variable names. They're special objects. They're special objects, but you can name the variables anything that you want. As far as the advantage of using this over the procedural interface, I think that will become more clear when the graphs that we're making are a little bit more complicated. So we are going to be doing like subplots during this workshop, and I think that I think that's where the object-oriented interface becomes very powerful. And then, yes, an important thing to know is that this plt.subplots always returns two variables. The first one will be a variable that represents your figure. The second will be a variable that represents the figure axis. So the axis is like this part, the X and Y axis, and that's why we add data to the axis. Okay, so I'm going to continue working on my figure. I want to just add 1, 2S, and 3S. So I'm just actually going to copy these lines and just modify them a little bit. So I'm actually going to put this all in the same cell. Because if I add this 1S several times, did I not cut? Okay. Just to be neater, I want to put this all in the same cell, so I'm going to get rid of this cell. Okay, so this is what we have so far. So if you want to add more things, you can use additional plot commands. Important things to know right now is that instead of using plt.plot, we're using ax.plot. And I'll just demonstrate maybe a consequence of this. Let's say I wanted to, so let's say I want to make another plot. I could do fig2 ax2 equals plt.subplots. And then I can do ax2.plot r, I'll just do 3s. S orbitals. So now I've got something like 2 figures, but if I want to say add something to this figure, I can still do that in a different cell. Like if I want to add something to Ax, I could do this later. You could, of course, still also do it in this cell. It's just a little bit, this is a simple example, so it's probably not clear yet what the benefit is. Okay, so this is the object-oriented interface. I want to take a little bit of time to make this figure look a little bit nicer. So I want to talk a little bit about how we could customize the appearance of this plot. And actually, I'll leave this one so that we can see what it looks like. And then I'm going to scroll down and I'm going to make this one look really similar. I'm going to make it look the same starting out. And then I'll go over like some plot customization on how we can make it look nicer. Okay, so starting out, I've got fig2, ax2 equals plt.subplots. And then I've plotted my 3 data sets. So when we customize our plot, there are 3 topics that I'm going to discuss today, maybe 4. The first is setting the colors in your plot. The second is setting the labels and the legends. And the third is setting the X and Y axis ranges. And then we'll also talk about like font size on the labels. Okay, so for Matplotlib, you can change the color of each individual line by setting the color property on the line. So if I decide that I want this 1S line to be a different color, I can come here after data and I can type the word color and then an equal sign. And then in quotes, I can type whatever color I want. So there are a set of named colors that you can use. So for example, I could say color equals red, and that's going to make my first line red. I think some other named colors are also things like blue, green, magenta, et cetera, et cetera. But when you're creating plots, you can also use something called the hex value to specify the colors. So a hex value is a set of numbers that represents a color. And they're very widely used in, say, HTML or other computer settings, I guess. But so here, I'll send this link. This is just a website that you can use to look up hex values for colors. There are lots of resources for things like this. But so, for example, this color that I'm looking at that's right here is represented by the hex value #FF5733. And if I wanted my line to be that color, I could select that and copy it. And then I could list that as my color. Yes. And we've had someone share, no, make sure you don't have space, I think. But now you'll see that this color is sort of the custom one that I chose from this HTML color codes. So there's lots of different colors that you can choose from. Let's see. Maybe this website I chose isn't the best, but if you Google something like hex, like color picker, you should be able to find a website that has these hex values for you. Dr. McDonald has also mentioned, and so Dr. McDonald has also mentioned that, say, different organizations may have branding guidelines, so such as your university. And if you do something like search your university branding guidelines, you might see that they have a web page that lists like hex values for your school colors. So if you wanted to do something like make a plot with very specific colors to match a sport team or to match a university, you could look up the branding guidelines and do that. While people are figuring out there's some colors that they might want to use, I'll also point out some other additional resources. Say if you're looking for, say, color schemes for your plots, which I remember I used to do when I made a lot of plots, you can do something like Google like color schemes, and you might be able to find a website that has different color schemes for you. So you could pick out, say, a particular color scheme and use those hex values for your plots. Yes, that's a good point. It is good to be aware of, say, colorblind friendly color schemes. So you may be able to find information about that as well. Okay, so I am going to go ahead and put in the colors that I picked out, which the colors that I picked out previously, of course, but I picked out colors that, I picked out some colors to represent MolSSI. So we use red and gray a lot, but then I also picked a blue that I think looks good with it. So mine were 2, 5, 6, 5, E, 8, and let's see, then I did okay, so those are my colors. So I did a blue, red, and dark gray. Okay, so that's my plot customization so far. Let's continue with some additional plot customization. So we might also want to do something on this plot, like label our data. So we might want to know what this blue line and red line and gray line is. So let's imagine we're preparing this for a poster that we're making for ACS, maybe, or some other place we're going to be presenting our data. We probably want to have this graph be labeled. So we can continue. I'm going to continue working here in my cell to make this plot look even nicer. The first thing that I want to do is I want to create a legend on my plot. So to create a legend on my axis, I can do ax2.legend. And this is something to know when we are using our data, when we're adding data this way with a pandas data frame. Usually when you use Matplotlib, if you want a legend, you'll have to include another argument here called label. Since we're using a pandas data frame, we don't have to add the label. It will just take this column name as our label. So if I do ax2.legend, it's going to add a legend for me. So by default, Matplotlib is going to try to find a nice place to put your legend. It's going to optimize sort of, it's going to put your legend where it covers up the least amount of your data. So if you had like sort of the noisier, more data points, it would kind of make it so that the legend didn't overlap. It would do its best to make it so that the legend didn't overlap your data. You can also set the location specifically for that. If you wanted it on the lower right, for example, you could add another argument to this legend function. And then we're also going to set the label for the x-axis and the y-axis. So I'll do ax2.set y-label, and I'm going to call it psi. And then I'll do ax2.set x label, and I'll call it R. Okay, and I'll execute that again just to see how my plot's coming along. Now I have a legend, I have an X label, and I have a Y label. So as scientists, we tend to use, say, mathematical symbols or use symbols pretty commonly in our in our presentations. One really nice thing about Matplotlib is that it supports mathematical equations and symbols, and it uses something called math text. So if we want, for example, this psi label to appear as the symbol, there's a special way that we can do that. So to make the symbol appear, we can use the dollar, we can type a $sign. So have a $sign in front of this, where we want the symbol to be, then a slash, and then we put another $sign at the end. And now you see that we have our symbol here instead of the name. So this is true for any symbol that you want to use. You would put a $sign and then a slash, and then you put the symbol name, and then another $sign to end this. The uppercase, like if I put uppercase P, that's going to put the large psi. If I put the lowercase, that's going to put the small. So you can try that out with some other symbols as well. Okay, and the next thing I want to do is I'm going to set the limit for my x-axis. So I'm just continuing to make my figure nice so that I can use it on my poster and my presentation. I'm going to make it so that I don't kind of see this white space at the end. I want to get rid of that. So I'm going to set the x limit for my plot, and I'll tell it to start at 0 and go up to 14. And I'll execute that. So to show setting the x limit. And then sort of the next thing that I kind of want to change is maybe the size of this font. So I think that typically for presentations, you'd like your font size to be larger. So I'm going to change the font size for my Y label. So if I want to make this larger, I can just add an argument here called font size. I'm going to set that equal to 16. You can also change the font size in your legend. So I'm just making my labels a little bit larger, and in my legend a little bit larger. And then if you want to change maybe the size on these tick marks, this is ax2.tick params. I'm going to do it for both on both axes, my major labels, and I can set the size of those. So I'll just pause here so that you can see this. But this is demonstrating setting the X limit of the axis. We can set the font size, and we can also set the label size of the axis ticks. So a point I'm trying to make here is that Matplotlib is extremely customizable. We can set our specific colors that we want. We can change the font sizes to anything that we want. So pretty much everything in this this figure is controllable and accessible. To go back to the idea of the object-oriented interface, I want to show a little bit here to give you an idea of more of the implications of this object-oriented interface. So everything that is on this figure, everything that's on your graph is accessible in those variables and can be kind of set, or you can get information about it. So I have my variable called ax2 that represents my X and Y axis. So for example, I can do ax2.lines, and that's going to give me information about the lines on this plot. So it's showing me that I have 3 lines. You can say index into this and do something like get color. And it's going to return the color to you. So this is a consequence of Matplotlib's object-oriented interface. And that is that you can access almost anything on this plot through objects. Okay, so what we've been doing so far is we were taking our original figure, which if I scroll up, this is just sort of what the figure looks like if I just add my data to it and don't really do anything with it. I was taking this original figure and I was making it a little bit nicer so that I could, maybe add it to my poster. So here it is. This is my final figure. I've got my axes labeled really nicely. I have the font set to a size that I like. I've got this legend here in the corner. So now I think I'm ready to save the figure. So saving the figure is going to be really important for using it later, because you probably don't want to just take a screenshot here. You'd like to maybe save it and make it high quality. So to save a figure, we're going to use this fig variable that we haven't really done much with yet. So we'll do fig and then dot, and the function that we'll use here is save fig. And then in parentheses, we put the name of the figure that we'd like to save. We can do sorbitals.png. So this will save a figure for us called sorbitals.png. If we want to increase the quality of the figure, we can put a comma and add an argument called DPI. And DPI stands for dots per inch. I think by default, it's something around 70. If you want it to be a higher quality image, you add DPI and then put an equal sign, and you can make this number larger. So typically for publications, and when you execute that, you won't see any output, but if you navigate back out to sort of where your files are, and maybe I have to refresh this. Oh, there it is. Maybe it was there already. So, oh, I saved the wrong one. We need to make sure we save fig2. So you should have that PNG file appear. So there is your figure. And you'll see if you did that DPI equals 300, it's pretty high quality. You can zoom in on it. If you want to maybe make, so one thing that I also find useful, so a few options, you can save fig. Another thing you might want to do is make part of your figure transparent. So if you want this portion outside of the graph to be transparent, you can add, so I'll do DPI 300, and then I'll add another keyword called transparent, and I'll set that equal to true. And what that will do is make it so that this portion of your plot is transparent. It will leave, I think it will leave this part white. So that can be really useful if you're making figures for presentations. And then the sort of last thing to know about is that this PNG is an image format, but you can also save figures using a format called scalable vector graphics. And that that's something that it's not a raster image. It's just like very high quality. You can load it in like Adobe Illustrator, but you can also save SVG using fig2.savefig. You can just specify SVG here. And yes, you can also save it as a PDF. If you need to see any part of the notebook, let me know. So what we've learned so far is plot customization, setting limits, using the increasing font size, using symbols, et cetera, et cetera. So hopefully this already gives you an idea of sort of how you can use Matplotlib to make some really nice images. Okay, so the next subject in Matplotlib that I want to talk about is subplots. And so this is the part where I said that the advantages of the object-oriented interface were going to become more clear. So it is possible, in case you're wondering, it is possible to use subplots without doing the object-oriented interface. I have seen people do that before, but I think that the object-oriented interface makes working with subplots easier. That's my opinion. So we'll talk about this. So I just made this next cell into a markdown cell. I'll do a subtitle and I'm going to call it subplots. And I'll write a little note. Subplots is putting multiple axes on the same figure. Okay, so we'll do subplots here. I'll do fig3, I guess, just to keep my other variables, fig3, ax3. And this time I'm going to set it equal to plt.subplots. And then I'm going to put open and close parentheses. And then you can put numbers in here. So I'm going to show 2, 2. So when we do 2, 2, what this is going to tell Matplotlib is that I want to make a figure that has 2 rows of axes and 2 columns. So we'll see what that looks like. You'll see this displayed here. So we've done plt.subplots. We have 2 rows, 1, 2, 2 columns of figures. You can edit this, so I could do something like 2, 3 to get 2 rows with 3 columns, et cetera, et cetera. So this is how you create a figure with all of these, with multiple axes. So an important thing to know about the variables that we've created here, and this is where the distinction between a figure variable and an object variable becomes important, is that now this fig3 represents this whole figure, and this ax3, I'm going to just examine what this variable is. I'll do type ax3. It is a numpy array. So now we have a variable that is a whole figure. So this is what we would call, say, fig width. And then ax3 is a numpy array. And very importantly, if we look at our numpy array, so I'm just going to do ax3.shape. Its shape is 2, 3. So it's 2 rows, 3 columns, which you'll notice is the same as what we created with this plt.subplots command. So now each element in our numpy array represents a different axis. So if I want to add data to this first one, I would select row 0, column 0, and then call plot, and it would add data to this plot. So this is where sort of the object-oriented interface becomes convenient, because I can selectively add data to whichever one I want to add to by slicing into this NumPy array that I have. So just previously, we created a plot where we had 3 sets of data on one axis. Let's make a figure that uses subplots to have these 3 beside each other. So I want to create, so for this, I'm going to have plt.subplots. I'm going to do subplots with 1 row and 3 columns. You'll notice here that, so I'm going to do the same thing that I did last time, and I'm going to kind of, well, I'll leave this here as a demonstration. No, I'm gonna do the same thing I did last time, and I'm going to work in this cell and make the figure look nicer and nicer. So I'm just going to keep working in this cell. So we have our figure variable, we have our axis variable. One thing that I like to do is I like to use a function called tight layout. So you'll notice here that this is overlapping a little bit. If you use tight layout, it's going to adjust it so that these are not overlapping. And then I can start adding data to my plots. So I mentioned that that ax3 variable is a NumPy array, and I can access, say, this first one by just selecting that the element that represents it in the NumPy array. So if I want to add a plot to this first axis, I'll do ax3, and then I'll get index 0, and then I'll call plot, and then I'll do my plot command the same as we've done before. So I'll do r, comma, 1s, and then I'll do data equals s orbitals. And I'll see that I have added my data here. Okay, so I want to do an exercise. Add 2s and 3s to appropriate axes. So I want you to, as an exercise, add 2s and 3s. So 2s will go on this axis, 3s will go on this axis, and then see if you can figure out how to add your axis labels. Okay, so we had a question: if we were working with a multi-row plot, we would specify which plot. So I'll demonstrate that. So if we had a multi-row plot, I'll do so we had something like 2 rows and 3 columns. So you would slice it sort of the way you would do a NumPy array. So if I wanted this one, that's row index 1, column index 1. So it would be like this. So row 1, column 1. So this is sort of just the way you slice NumPy arrays. So you'll see I added that one there. Yep. And Matplotlib gets even fancier with this. There's something called the grid spec that I actually don't know how to use. Okay, so let's add this. I'll do ax3 1 is 2s, and then ax3 index 2 dot plot is r, and then 3s. Data equals s orbitals. And that's going to add our three lines. So I could continue to customize these in a similar way to what I did before. So I could change my color. I can change my colors. I can set the X and Y limits. So one thing that you'll notice here is that these are on different scales on the Y limit. I want to see if this works. I know that this works in some contexts. So one way that we might fix this on a subplot, so I just added another keyword here. If you put share Y equals true when you create your subplots, so you'll notice now that we only have one Y-axis labeled. It's over here at the side, but this puts them all on the same Y-axis so that they now all go from the same range. You can also, I think, do share X equals true if you'd like for that to also be true. I want these to kind of, well, let's try. And then I think I will add my labels. So I'll do ax3 0.set x label r. I want to see if it adds it for all of them. Okay, so it's only adding it for one. So one way we might sort of add labels to all of these is I'm going to loop over my axes. So I'll do for axis in ax3, and I'm going to do axis.set x label r, and I'll do axis.set y label, and then I'll make my symbol. And then I will do, I'm going to make sure I have a legend. And then I will set my X values. Then, yeah, I'll do 0 to 14. Need to write the word in. Okay, and now I have this data on 3 different subplots. You'll notice here that this is cutting off our symbol on this side. So actually, usually if you use tight layout, you want to make it maybe the last thing. As far as the question on share X, I think that share X is more relevant when you have more than one row. Oops, big 3.type layout. I think it's more useful when you have more than one row of data, and in that case, it might only label the bottom. Yeah, I think it will set it automatically on the same range, but these were all on the same range anyway. Okay, so that is working with subplots. Okay, we've resumed the recording. Unfortunately, I forgot to start it after the break. So we are creating a contour plot. We have read in our data using pandas. We're reading in a file called px2d.csv. Then we picked our X data and our Y data. So for a contour plot, that's a type of plot where we have an X, maybe X, Y, and Z values. And we're going to represent our Z values using colors. So I sliced my X values, I sliced my Y values, and then I sliced my Z values. And then we created contour plots. So we have fig, ax, plt.subplots. We did X and Y. And then we gave our Z values. And then we're just making it look nicer. Okay, so let's return here. And let's talk about the type of color map that we might want to use for this data. So I'm going to click back over to choosing a color map. So we said that there are different classes of color maps. There is a sequential color map, there is a diverging color map, there are cyclic color maps, and there are qualitative color maps. So out of the classes of color map, does anyone want to share the type of the class of color map that they think we should use? So someone said diverging, and I agree. Yes, so for this data, we would probably want to use a diverging color map. And to decide that, we'd have to think about what we know about the data that we're representing. So we're representing basically the wave function. It has positive values, it has negative values, and it centers around like 0. So a diverging color map is going to be a good one to use in this case. So let's go down to our diverging color maps and see ones that we could pick. So here are our options for diverging color maps. It depends. So some of these color maps center around white, which I like for this data. So you just kind of have to think about what you like for the data. I would kind of want 0 to be represented by white. And then I also like the ones that are like blue and red for this data. So we could maybe try seismic or EWR, cool, warm, but it's really up to you. So for the rest of our session, maybe just pick, actually, I think what I've used in the past is this RVBU. But for the rest of the session, maybe just pick one that you like. And then know that if you pick a different one than me, your plot is going to look a little bit different than mine. Okay, so there we are. And now we have this color map with our different color map. Okay, so by default, it's only going to show us 6 different levels or 6 different colors. We probably want to have more levels than this, or more, this is called levels. We probably want to have more colors than this. So I think the way that we can specify that is we can do I think someone showed us last time that we could do this, just put the color. So you can put comma levels and then an equal sign and then a number, and that's going to change the number of colors that you have representing your data. So you can pick, something else, something higher if you would like a more detailed image. Okay, so I might want to do a few more things here. I might want to set my labels. Wow, how exciting. Isn't that amazing? Once you set the number of levels, it looks so different. So I'll do, I'm going to set my Y label and make sure I set this on the correct one. And of course, you can change your font size and everything. You can change these tick marks if you'd like. But now this is a little bit nicer. So you can, of course, use those same things that we learned earlier to set the font size. So that is creating contour plots. So I want to compare this to sort of what we got initially. So this is our initial contour plot where we just called the contour function. This is where we called, well, and then we did all this down here. So we changed it to contour F. We set the aspect ratio. And then we chose our diverging color map. And then we also increased the number of colors. So you can really see how sort of the choices that you make when you're making your plot can really affect the way that people are able to see your data or affect the way the plot looks. Okay, so that was contour plots with Matplotlib. Okay. All right, so that is a lot of visualization using Matplotlib. I want to now take some time to talk about doing visualization with a Python library called Plotly. And Plotly, you might have heard of it, but it is a library that is used to make plots in your browser specifically. So we've been working with Matplotlib. With Matplotlib, you can put these plots, you can save them as PNGs. Plotly is a library that's used to make interactive plots, and it's usually exclusively used, I would say, in your in an environment like a Jupyter notebook, but you can also put it in regular scripts. So let's go back out to our main window and create a new Jupyter notebook. And let's call this one Plotly. So we'll call it Plotly Intro. Okay, I'll create my markdown cell. Okay, and I'm going to read in my S orbitals data again. So we're just going to demonstrate how to create plots using Plotly. It's going to be very similar to the plot that we created in the first part of this tutorial. So I'll do import pandas as PD. And then for Plotly, I'm going to be showing how to use an interface to Plotly called Plotly Express. If we get to subplots and Plotly, we won't be able to use Plotly Express anymore, but Plotly Express is an interface to Plotly that's made to be easy to use, and that's why it's called Express. So we'll do import Plotly.express as PX. And then I'm going to read my data in. So I'll read in that S orbitals file, and I will check what I have. Check to make sure that that read in correctly. Oh, one thing I did mean to say, just a minute. So one thing I did mean to say on, before we finished up contour plots, I'll pull this up real quick, is that there is, if you would like to practice contour plots, there is a file in here called A1A2ENE.CSV. And this is data associated with an alanine dipeptide. So it's basically like a Ramachandran plot. Let me pull up. So this is data where if you want to visualize it, you do have to reshape the data. So you could try to do that. It might be kind of difficult, but if you make the plot, this is what that will look like. And that's included for you to practice later if you would like. It's also on our online lesson materials. Okay, sorry, I meant to say that before we moved on from contour plots. Okay, so we are doing interactive plots with Plotly Express. I have read in my S orbitals data, and now I'll show how to create a plot with Plotly Express. So I'm going to create a variable called fig. I'm going to set that equal to, and I will do px, which for Plotly Express. And then we want to create a line plot. So we'll do px.plot. So for those of you who are getting module not found, no module named Plotly, that I think I forgot to include it if you're using your own computer. So you can install it in a way similar to if you did NGLView, that you installed NGLView. I think that you can also do this. So try executing this. And I won't execute it because I am not on my own computer. I forget that Plotly doesn't come with Anaconda sometimes, but if you're using Compute or NanoHub, it should be installed there. Yes, okay, so we'll do px.line. This is how we do a line plot. And then it's a little bit different. First, we give the data frame, and then we say x equals r, y equals 1s. Okay, nothing will show up, but when we're using Plotly Express, we actually have to use a function called show. And this should show your plot. So there, mine took a little bit of time. So this is the plot that Plotly created. You'll notice that it looks, I mean, it doesn't look that special just looking at it, but if you mouse over, it is much more interactive than the Matplotlib plot was. So you'll notice that it gives us a little, over our cursor, it's going to label where the data is. It also has like options for zoom. So I can go up here and I can click this zoom button, and then I can zoom in. I can click here to reset the axes. So it just has a lot of, it's just very interactive plot, and it's nice. It's nice for using in Jupyter notebooks. Okay, so if we want to add more lines to our plot, it's a little bit different than Matplotlib. So I'm going to do Fig2. And I'll do S orbitals X equals R, and then Y equals, and then if I want multiple Y values, I make a list of Y values instead of using the command several times. Oh, make sure you show the right one. Oops, I was like, oh no, what's wrong? So there, now we have, you do fig2.show, and we have those three on the same plot. And let's see, I think that there's a button here. Oop. There's a button somewhere to change the way that this behaves so that they all show up at the same time. Or maybe that's a setting. Now we have a plot with all three values that is interactive. Okay, so Plotly I really like, but sometimes you might find the syntax to be a little bit confusing if you are just starting to use Plotly. So Plotly really likes to use Python dictionaries. So I want to talk about plot customization with Plotly. So let's say that I want to add a label to my axis. You'll see that it has sort of auto-filled in an X label that looks the way that we want it to, but it doesn't have a good Y value. So in Plotly, if we want to add labels to our change the value of labels. So here it's kind of given us some generic things. It's given us R, that's correct, but then our Y value says, our Y axis says value, and our legend says variable. It does, do I need to show a different part of this?
Someone asked if you could go up,
Oh, okay.
But going up was just demonstrating the one line plot. Yes. So.
Yeah. So I want to show how we can change the names of these. And to change the names of these, we have to use a Python dictionary. So I am going to, let me create a variable called plot labels. And I'm going to set that equal to, and then I have to use a dictionary. And And then I will say what it is labeled as R, I want to be R. So if you're unfamiliar with dictionaries in Python, this might look a little confusing, but in Python dictionaries, you have you'll have something here. This is a dictionary key, and then a colon, and then the dictionary value. But what I'm saying here is R can stay as R, but I want what it has as value to be, and I'm going to use, Plotly also supports these mathematical symbols. So I can say I want value to be psi. And then I can say that I want variable colon to be orbital. Okay, so I create that variable, and then I'm just building several images that looks very similar. Although px.line s orbitals, and then x equals r, y equals 1s, 2s, 3s. So this is the same as we made before. And then I will add labels equals, and I'm going to set it equal to that variable called plot labels that I created. And then I will do fig3.show. I guess that doesn't work. Do I need this here? No. I wanted to make it so that I forget how to make it work on multiple lines. Oh no, I was right. I just had this mistyped. I need to actually read my error messages. Okay, so here is my plot that I have now created with Plotly. You'll see I have my psi symbol here. I can hover over. It's now labeled correctly. One thing about Plotly is I really like Plotly for making figures in Jupyter notebooks because it's very interactive, but I find that the syntax or the way that you type things can be a little confusing sometimes, like typing the labels this way is a little bit confusing, but it's just something that you get used to as you work with Plotly. Okay, so great. I want to show a little bit of customization with Plotly. And again, this is something that's going to look probably a little bit strange to you if you haven't used Plotly before. And this is where I think also I got a message about what I was forgetting, which was that in Plotly, we can turn on or turn off lines by clicking them in the legend. So that's what I was trying to remember. Apologies. But that's just further demonstrating how interactive the plots with Plotly can be. So you can turn off, say, 1s by clicking on it here in the legend. Okay, so back to customizing the Plotly plot. This is where our experience with the object-oriented interface of Matplotlib is going to help us, because you might have noticed that in Plotly, there is no procedural interface. We have this fig object that we're working with. And if we want to know information about the layout of this figure, we can do we'll do fig3.layout. And this isn't printed very nicely, but you're going to see that we have, it says layout, and then it tells us what our legend says. It says what our margin is. Then there's some information about our x-axis. this domain is the, actually, I'm not sure what the domain is. Then it has our, I thought it was our range, but that doesn't seem to be the case. Anyway, it has our title, et cetera, et cetera. So the information, so this is a figure variable or a figure object. It has all of the information about the layout under this fig. So you'll do the fig name dot layout, and you can see the information here. If we want to change what is in this layout, so let's say that we want to change the layout of the function, or change the layout of the figure, we can use a function called update layout. So I'm going to demonstrate some things that we can do in this update layout function. So let's say change layout of figure. So I can do fig3.update layout. So I'm just going to show, so for this, the way that you would look up sort of how to update the layout is, or more detailed information is maybe the Plotly documentation, but I'll just demonstrate some things that we can do. So I might do something like set the font family, and actually there are ways to do this in Matplotlib as well. We just didn't talk about them. So maybe I want my font to be Times New Roman. I can set my font size. Maybe I want my font size to be larger. So maybe I'd like it to be something like 20. And maybe I want my plot background, I want it to be a different color. So I'm going to set my plot BG color. And I'll just say white, although I imagine that you can use hex values here as well. So I'll do fig3.update layout and then fig3.show. And now you'll see I have this figure. It has a white background. We're using Times New Roman font, and the font is also larger. I don't think this looks particularly good. I think maybe the what they had originally was a little bit better. You can make it so that there are grids. So I figured out how to do this earlier, and I can paste this if people want it, or it's also in our online lesson materials. But you'll see here that I've, on my x-axis and y-axis, I've added grids. Paste that in case people want it. But just the point here is that if you want to change how your Plotly plot looks, you are going to be changing what is in the layout, and you can use the update layout function to set the font family and the font size. And I've added my grids here, and then I've also added a 0 line. Okay, so you can export these figures, but I think that I actually need to talk to someone at NanoHub and someone at ChemCompute to make it so that these figures can be exported, because I believe that that exporting Plotly figures requires a package that is not installed. But if it was installed, I can try doing it and see if it works. I can do fig3, and if you are on your, if you're on your personal machine, if you'd like to export the images, you would have to do pip install. So exporting images from Plotly requires another package that is not installed with Plotly automatically. I'm going to see if this works on I'm going to see if this works on ChemCompute. Okay. And it doesn't, because yes, so everyone will have a download PNG button. And that will save it to your downloads folder. But if you use this save image, write image figure, write image, it's a little bit more customizable. It will also let you set your, you can also use it to like say set the quality. You can use it to save PNGs. So it's nice to have, but you can always use this download plot as PNG button. Let me check if there's another one that's also really nice about Plotly. If you'd like to keep it interactive, there's also a write HTML function. Let me see if this works. Okay, so you don't need that other package to write the HTML. So this has written a page called sorbitals.html. And then I think if you look at it, so then you have just a HTML page that you can open in a browser. So it's like a standalone page. So that's pretty nice. You'll see that this has not been preserved. When I say this, I mean the symbol. So I have to add something special for that. And I'll say include mathjax equals CDN. Let me export. Let me refresh that and see if that worked. There we go. Okay, so that is an intro to Plotly Express. I think the download write HTML is a pretty cool function. So you could make a really nice plot in Plotly, say in your Jupyter notebook, then you could write the HTML and you could send it to someone and then they can open it in their browser and see the same sort of interactive plot that you created. So there is a lot more that you can do in Plotly Express. It has lots of different plot types built in. I think a really fun one, I'll show from the lesson materials. A really fun one is a map. So actually, if you ever see me show maps in MolSSI presentations, I've made them with Plotly. This is an example of a map using scattered geo. So we were just using line plots in Plotly, but you can also do scatter plots on like maps, and there are a lot of different types that are built in. Okay, so that is the intro to Plotly, and now I want to give us a choice on sort of what we do next, because there are two different things that we could do. So we can either do visualizations of a protein using a package called NGLView, or we can look at how to use Plotly to make subplots. And using Plotly to make subplots is a little bit complicated. Okay, we've got 7 for protein visualization using NGLView. And when I say protein visualization, I mean like an interactive picture of a protein from a PDB file. Okay. Oh, is it more than half? Okay, all right, we'll do that then. Sorry for all of you who were wanting to vote for subplots in Plotly. All right, so we will do that. The other option I would have given you is how to do subplots in Plotly, and I'll show you that is online. But here is sort of what the subplots would look like in Plotly, and you would have the symbol here. It just doesn't show up on the internet for some reason. But it is a little bit more complicated. It's the syntax is different. So, okay, but we've decided we are doing protein visualization using NGLView. So I've included a PDB file here called F3FGU, and we will be using NGLView to load in that PDB file. So I'm going to create a new Python 3 notebook. And I'll call this one NGLView. You can use this with any PDB file. So in this portion, we'll be looking at how to visualize a PDB file using NGLView. NGLView is a molecular viewer program. It's made to work specifically with the Jupyter Notebook. You can use it to read in PDB files, but you can also use it to read in, say, molecular dynamics trajectories. It is basically made to work with a lot of different, it's made to work with a lot of different formats, molecular file formats. And if you want to see the list of those formats, you can go to the NGLView documentation. So today we're just going to be using it to view that PDB file that I mentioned and talking about different representations that it can do, and sort of some different capabilities. So what you can do with NGLView is there's just like everything that I'm showing you today, there's a lot more that you can do with it that I won't have time to show you. But let's do import NGLView. And typically when we import NGLView, we import it as NV. And everyone should have that one installed because I think I remembered to tell you to install it if you're using it on your own computer. And both NanoHub and Can Compute also have NGLView installed. So we will create a variable called view. And we're going to use a function in NGLView called show file. And then in parentheses, we're just going to type the name of the file that we want to show, which we are looking at 3fgu.pdb. Okay, that should read in our file. And then if you want to see the view, you just type it as the last thing in a Jupyter Notebook cell. And now this should show up. So this is the PDB file that we read in. It just centered on, if you double click on a certain thing, it will kind of like center on that. Well, so you see I have a label here. So this is an interactive view. I can click and drag to rotate it. I can use my mouse to zoom in. So I'm zooming in here on this ligand. I think that it's labeling, is this a bond I clicked on? Something like this. You can also drag this, click and drag this to make it larger. I'm gonna kind of reset this view. So this is the default view. So you'll notice that NGLView puts a default representation on this that it thinks is nice for us. It's representing what we call the ligand and the protein in different ways. So by default, the protein is shown in something called cartoon representation, and the ligand is shown in ball and stick representation. So you can see that when you zoom in. So we can change the representations that NGLView loads in. We can change the colors of these. So let's look at different representations that we might have. So I'm going to take my view. I'll clear the representation. So the first thing I have to do is remove the representation that it currently has. And then I'm going to change the representation, and I'm going to make it all into what we would call ball plus stick representation. So there are a number of different representations built in. Ball and stick is one of them. Some other available representations are, and I'm just going to write cartoon. That was the one that was loaded in automatically for proteins. There's also this one I just used. There's also one called space fill. And there's one that I like called hyperball. So you could try filling in different ones here to kind of see what those look like. So this is space fill. And then there's also, say, hyperball. I think this one looks cool, maybe not for a protein. But you can change the representation for your molecule. Execute the cell. I am going to create a new view. And I want to show how we can select different parts of the molecule. So I'll do view2 equals nv.show file fgu.pdb. And then I'm going to clear the representation. Okay, so I've shown how you can clear the representations and then add the representation. And in this case, when we add the representation, it was applied to the whole molecule. NGLView also has a set of keywords built in that allow you to apply representation to only certain parts of the molecule. So let's say I want to represent the protein and the ligand differently. I can do view.add representation. Let's say I want to use the hyperball representation, but I want to apply it to only the ligand. So some of the keywords, you can use the word ligand to apply it to ligand atoms. You can use protein to apply a representation to protein atoms. You can also select charge. For example, you can select things like charged residues, basic residues, water molecules, or ions. So those are other, there are keywords associated with each of those things. And then I can do view. I want to center it on the ligand, so I'm going to do view.center and type ligand. I'm going to make sure I'm doing this on the right view. Yes, it should be view 2. And then let's look at what we are creating. Okay, so now we have this view where we have just the ligand. In this add representation, I can also do things like specify the color. Again, there are built-in colors, so I could do red. I imagine that the hex colors that we learned about would also work. So you could also put hex colors here. Yes, and we are not seeing the protein because we cleared all of the representation. So it's only showing us the representation that we have specified. So here I've selected the ligand. I've chosen to use the hyperball representation and I've colored it red. I could also add in the protein. So I might do view2.add representation. Then let's do, let's see, cartoon. And I'll select protein. I'm going to make it color. We could try charge. Someone asked if we can color by charge. We can try and see. If this doesn't work, then I'm going to say we'll have to look up the documentation. It seems like something that would be desirable to do. And I'm going to actually make the protein kind of see-through. Yeah, I don't think it knew what charge meant. I think it just made it white. Oh, wait. Actually, it might know, because I'm not sure. I don't think charge is stored in PDB files. So it's possible that if you used a file format that had charges, this might work. But PDB files, I do remember from back in the day, don't have charges built in. But if you are a molecular scientist, you'll know that some some file formats do, like typically the file formats you do see your simulations would have some sort of charge built in, or if you use a mol2 file, those can have charges in. And I'm sure that NGLView can read those, but we're just using a PDB, which typically does not have charge information. So maybe that's why, but I'm just guessing. You'd have to investigate. Okay, so this is the image that we've created so far. So this view2.center tells us what part we want to center our image on. Here I've centered it on the ligand. So let's see what it looks like if we don't have this center. So if we don't specify center, you'll see that it shows us our whole protein center in this. But if I want to zoom in and center my image on the ligand, I can select that. Let's, let me see, add, maybe let me see if I can add ion. Let's see if that's a word. I want to, maybe I want to show my ions also. So here I've added another representation. I made the space fill, and then I selected the ions. Okay, so that is sort of a quick so if you want to make the viewing area larger, maybe this will answer your question here. Maybe this will help. If you click this, this will expand it to take up your whole screen. There's a little button in the upper right corner if you hover over it. You can also click and drag the corner. I'm not sure if that's actually making, well, I think it maybe couldn't make it larger because of my screen size. Let me try spin. There may be ways to set it programmatically in Python, but I don't know those off the top of my head. Okay, so saving this image, let's talk about how to save the image. I can do view, so this is saving image. And the function that we want is download image. If we put nothing in these parentheses, then it will make a file called screenshot.png, and it will save it to our downloads folder. So I'll demonstrate that. You may not be able to see this, but it's asking me what I want to do with it. And I'm going to say save. It's not showing up, but it will be in your downloads folder. You can specify the file name if you'd like. What was it? 3fgu.png. I'll do .png. And again, we can increase the image quality. So if I want to increase the image quality, in this case, I use a keyword called factor. And the default value for factor is 4, but the higher we set it, the higher quality our image is. So I can do something like set it to 6. And you can also make it so that the white portion of your image is transparent by setting transparent equal to true. You execute that, you should find that in your downloads folder. Oops, I've been saving view. I need to save view too. Oh my goodness. You're welcome. All right, so any questions? So this was a quick intro to NGLView. What I think is really interesting about NGLView is that if you use something like ND analysis, you can, like NGLView interfaces with ND analysis or interfaces with some trajectories so that you can actually make movies in the Jupyter Notebook. So that's really nice. It also, if you've used, there's a Python library called ptrash or pytrash. I think it's pytrash, that can be used to work with these, to work with, say, PDBs that makes the visualization even more powerful. Okay, all right. So before you leave, I want to show you a few things that may be of interest to you. And one of those is the MolSSI Education website. So you may have noticed a few times that I refer to this website, Scientific Visualization Using Python. All of these lesson materials that we've covered today, except the NGLView portion, which I am working on getting up, is available through our MolSSI Education website. So you'll see it has information. So I can click on the plotting with Matplotlib's procedural interface. So if you wanted to cover any of these again, they are available online. MolSSI Education has a website. It's education.molssi.org. If you click the resources tab, you'll see a list of different tutorials that we have. The one that we did today was the scientific visualization using Python workshop. And if you click on this, it's going to take you to that page I just showed you. You'll see a number of other workshop topics here. Some under programming, there are some under software development, high performance computing, etc. So I would encourage you, if you liked the workshop today, to check out more resources on our MolSSI Education website.